Dear students, now we are going to discuss the realization of full adder using half adders.
Implementation of full adder using half adders. It is a very important question. Okay. So here a full adder can be implemented using two half adders and one OR gate. The Boolean expression for the sum is equal to A XOR with B XOR with C. Here the carry expression is equal to AB plus ACN plus BCN. Okay. So in order to obtain the full adder in terms of half adder, we have to convert this expression in terms of XOR format. For that, we have to simplify this carry expression. So here we are going to use the method like this, simplification method like this. So AB as such plus ACN. Which term is missed out? B. So we are going to multiply this term with B plus B bar. Because we know that B plus B bar is nothing but 1. So plus B into Cn. Which term is missed out? A. So B into Cn multiplied with A plus A bar. So A plus A bar is nothing but 1. Okay. So next step AB plus A, we have to multiply inside. So we can get AB Cn plus AB bar Cn. Likewise here A B Cn plus A bar B Cn. So in the next step we are going to take the common term. So here AB is there, here AB is there and here also AB is there. So we can take the common term outside. We can obtain AB of, here it is 1. This term becomes 1. This term is Cn plus, here it is Cn. So 1 plus Cn plus Cn. So 1 plus any bit is equal to 1 always. Correct? That is the Boolean postulates. So 1 plus any bits, it's always 1. So this term becomes AB. Okay, because this value becomes 1. So here it is AB plus here Cn is a common one. Okay, so here Cn is a common one. We can take it outside from this two expression. So the remaining term is AB bar plus A bar B. So now we can obtain the XOR operation of A and B. So here we can write Cn multiplied with A XOR with B. So now we have simplified the given carry expression in terms of XOR gate. Okay. So for these two expressions, we are going to draw the full adder circuit. So here you can see A, B, C. So what is the sum? The sum is nothing but A XOR with B XOR with C. So A, B is given to one XOR. The output is A XOR with B and Cin is given as the input to the second XOR gate. So for this second XOR gate, one input is from the first XOR gate, that is A XOR with B, and the second one value is directly as Cin. So here it is Cin. It is A XOR with B. So finally we can obtain A XOR with B XOR with C. That is the value of sum. So next we are going to obtain carry. Correct. For this carry we have to multiply this A and B as such. So A and B is given, both are given to AND gate, we can obtain AB. So what is the next one? We have to multiply Cin with A XOR with B. So the output of the first XOR gate is A XOR with B here. So that is taken here. Okay, here it is A XOR with B. Okay, and this Cin is going there, right? From there we can take Cin here. So now we can obtain Cin multiplied with A XOR with B. So what is carry? AB plus Cin A XOR with B. So now the output of these two AND gates are added together using one OR gate. Okay, so now we can obtain carry from this OR gate. So from this circuit, we can tell the first XOR along with the AND gate is a half adder. So here we are having one more XOR with AND gate. It looks like a half adder. So we are having two half adders along with one OR gate to realize the full adder circuit. So simply we can say here AB is given, both are given as the input to first half adder. So we can obtain two outputs. One is A XOR with B, another one is product of A and B. Okay, so next Cin is the third input for full adder. So we are going to give the Cin directly to the second half adder. Output of the first half adder A XOR with B is another input. So from this we can obtain the sum as such, and this AB and the Cin together forms the OR operation. So this is the realization of full adder using half adder. It is very important one. So let me draw the realization of full adder using half adder here. So first we are going to draw the sum. Okay. So here A, B, these two inputs are given to one XOR gate. From this we can obtain A XOR with B. Correct? But we need to have A XOR with B XOR with C. So for that we need to have one more input C. So what we are going to do? We are going to give this C to one more XOR gate. So now one input is A XOR with B. Another input is C. So finally we can get A plus B XOR. It is not plus, it is XOR and C. This is the sum. So now we are going to draw the circuit for carry. So carry means A into B. So for that we have to multiply these two values. So we can get A, B here. Fine. So what is the next step? We are going to multiply this XOR value with one bit C. Okay, so this is AB. Okay, so next we are going to multiply this C with this XOR. So for that we are going to take this value A XOR with B and this C. Okay, so and both are given as an input to another AND gate. So now we have got A, B and C into A plus B. So these two are going to be added together. So for that we have to take this AB and this value. Both are given to one OR gate. So here we can add these two values. This is nothing but C into A plus B. Okay, so here it is nothing but AB. Finally we can obtain C. Okay, so this portion denotes one half adder. This portion denotes the second